Hello everyone, welcome to Electronically Connected. In this video, we will be moving further in our number systems and discussing what our decimal number system is more in detail and how to convert a decimal number system into the binary number system. We will be discussing two methods to do so, that is the 8421 method and then followed by the divisional method. So let's get started. Now let us understand what a decimal number system is. It's a number system which has the base 10. So if the base is 10, the numbers range from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Any decimal number can be formed using these digits ranging from 0 to 9 with its base 10. The number of digits in a decimal number can range from 1 digit to 0, 1, 2, 5, 3, 5, 9, 1, 0, 2. This is also called a decimal number. It doesn't have any fixed length. Let's understand now how to convert a given decimal number into a binary form. So the first method that we will be discussing is called the 8421 method. This is the most easiest method but a little tricky to understand. So let's pay attention more carefully. So each place in a number represents a particular power that we have discussed in a previous video. So let's say we have a 4-digit binary number B3, B2, B1 and B0. So each position has a particular power. So the B0, that is the LSB bit, is 2 zeros to 0 to the power 1 to the power 2, 3 and let's take one more to the power 4. So let's understand what each means when what it comes out to. So this is 1, 2, to the power 2 is 4, 8 and 16. So that means the maximum number that each position can represent is 16, 8, 4, 2, 1 because each position can either have a 0 or a 1. So it will be 1 multiplied by 2 raised to 4. So it will give us 16. 0 multiplied by 8 will be 0. 1 multiplied by 4 is going to be 4. Let's try and convert one decimal number into a binary form. Let's take 14. Let's try and convert 14 decimal to binary form. Now 14, what we have to represent over here is the maximum it can go. So 16 is more than 14. Hence, we will not be considering 16 in this place. What's the next maximum number below 14 is 8. So let's take 8. That means now we have represented 8. So 14 minus 8. How much is remaining? 6. Now what is the maximum number less than 6? That is 4. So we have 4. Now we have 6 minus 4. What is 2? Now 2 is here. So we have 2. And then we have 0. That is 1, 1, 1, 0. This is equal to 14 in its decimal form. I hope this is clear. Let's take another example. Let's take the example as 28. We need to convert 28 into decimal form. Now, we have a number 16 which is less than 28. If we want to understand what is the next number after 16, that is the bit 5. So that will be 2 raised to 5 which is equal to 32. Now 32 is greater than 28. So if I say 1 under 32, that means all the 32 gets counted in the decimal form. So 32 cannot exist over here. So that means the next number which is closest to 28 is 16. So I represent 1 here. That means we're going to subtract 28 and 16. What we get is 1 and 2, 12. Now the next closest number from 12 is 8. So we take out 8. So we have 12 minus 8. We have 4. Now again, luckily we do have a 4. So let's say 4. Now 4 minus 4 is 0. So we don't need any more digits. So 0, 0. So 1, 1, 1, 0, 0 is 28 in its binary form. Let's take another example and then we can move on to the next method. Let's take an odd number, 25 in its decimal form. Now the closest number to 25 over here, we cannot take 32 because it's more than 25. So we move to 16. So 25 minus 16, we represent 1 over here. So we have 9. Now 9. What is the maximum number less than 9 is 8. So we represent 1 over here and we subtract 8 from here. We have 1 remaining. So under 1, we just write 1 and these two 4 and 2 is 0. So in the binary form 11001 is equivalent to 25 in its decimal form. Hope this method is clear. Let's move on to the next method. So let's discuss now on the second method. In this method we're going to take an example 57.25. This is my decimal number. Now 57 is called the integral part of the number and 0.25 is called the fraction part. And here we have 10 as my base. So the rule over here is we need to divide the integral form and the fraction form is multiplication. So by what will we multiply is the base that we want to convert to. So we want to convert to a binary which has a base 2. So we'll be dividing the integral number by 2. Till then we don't get the quotient is equal to 0. And we're going to keep a note of its remainder. And similarly, we're going to multiply the fraction by 2. Till then, we are not able to multiply by 2 anymore. Let's understand this further. Let's focus first on the integral part. So we have the operation that we're going to perform. We're going to make a note of my quotient and my remainder. Remainder is what is going to be my binary number. So we had 57. We're going to be converting 57.25. So we have my operation 57 divided by 2. Now 57 divided by 2, my quotient is 28. And because it's an odd number, so we have a remainder as 1. Now further 28 divided by 2, which is 14, and now my remainder is 0. Moving forward, 14 divided by 2, 7, and my remainder is again 0. 7 divided by 2, we have 3, and my remainder is 1. Now we have 3 divided by 2, which has 1, and my remainder is 1. Now, we will still go further. We have 1 divided by 2, which will give me 0. And 1. Now, point to be noted is this last is my MSB bit and the first bit that we observed is my LSB bit. So we are going to write from bottom to top. So just the integral part, so 57 in its decimal form can be represented as from the MSB bit 111001. This is the binary representation of 57. Now moving to the fraction part, that is the 0.25 part of the number. So we have to multiply, according to the rule, we have to multiply by 2. So let's understand this. We have 0.25. We are going to be multiplying this by 2. What is the answer we get is 0.5. And what we are going to be noting is the number next to the dot. So we have 0. Next we have 0.5 which is going to be multiplying by 2. Now the answer here is 1. So the number that we note over here is 1 because it's 1.0 and hence 1. After this is done because if we go further, we have 1 into 2, then the number becomes 2 and now we cannot make this as a binary number and hence we do not consider this step. So my calculation stops over here and then that means 0.25 which we had in a decimal form can be represented as 0.01 in its binary form. Hence combining both of them together we have 57.25 which is equal to 111,001.01 in its decimal form. Hope this is clear. This method needs a little bit of practice, but I feel this is also a very easy method. It just requires a very basic multiplication and division that we all are very good at. This brings me to the end of this video. In the next video, we will be moving further with this topic and discussing how to convert the decimal number system to an octal number system and octal number system back to its decimal number system. Thank you for watching. Please like, share and subscribe to my channel. See you next time. Till then, happy learning.